Chapter 2 Electricity at Home 2 2.1 Lighting. Let's begin. A brighter room. Other than using more light bulbs, how can we improve the brightness of a room? Refer to Everyday Physics on page 50 to find the answer. 1. Light emission and electron transition. There is a set of allowed energy levels for electrons in an atom. When an atom absorbs a right amount of energy, it is promoted to a higher energy level. The atom is excited, which becomes unstable. Sooner or later, the electron will move from a higher to a lower energy level. Energy is released in the form of EM radiation, in which E equals HF, according to photon theory of light. In a mercury lamp, mercury atoms are excited by electricity. An electron in a mercury atom absorbs kinetic energy of a fast-moving electron moving between the electrodes, and then the atom is excited. The electron of the mercury atom moves to the higher energy level. Energy will be released when the electron returns to the lower energy state. As there is a specific set of energy levels in an atom, there is a specific set of frequency for the EM wave released due to electron transitions. 2. Types of electric lights. In the next few pages, we will explain the working principles of 3 types of light-emitting devices. They are gas discharge lamps, incandescent lamps, and light-emitting diodes. A. Gas discharge lamps. In the gas discharge lamp, electrons discharges through the gas between the electrodes. They need a few minutes to warm up to full brightness. 1. Fluorescent tube lamps, FTL. FTLs are efficient in producing visible light. Inside a FTL, electrons discharge through the inert gas between the electrodes at its 2 ends. It ionizes the gas and heats up the tube, and electrons collide with the mercury atoms and excite them. When an excited mercury atom returns to lower energy state, it emits UV light, which is converted into visible light by the phosphorus coating on the inside wall of the tube through fluorescence. The following simulation explains the working mechanism of fluorescent tube lamps. The main part of a fluorescent tube lamp is a sealed glass tube. It contains an inert gas such as argon inside under very low pressure. There is also a small amount of mercury in the tube. The inner wall of the tube is coated with phosphor powder. At each end of the tube, there is an electrode. When in use, a high voltage is applied at the 2 electrodes. Electrons are emitted from the negative electrode and they are attracted and accelerated towards the positive electrode. These fast-moving electrons ionize the gas inside the tube. The electrons and ions are then attracted respectively towards the positive and negative electrodes to conduct electricity, and we say the gas discharge. The energy of the electric current causes the mercury to vaporize at the same time. The mercury atoms are then excited by the collision with the fast-moving electrons and ions. Electron transitions occur to release the excess energy in the form of EM waves. Unfortunately, the EM waves are mainly ultraviolet radiation. They are absorbed by the phosphor coating, and then it emits a broad range of visible light for illumination purpose. This process is called fluorescence. In the lighting circuit, a fluorescent tube is connected with a starter and a ballast. The starter is used to set up the lamp. The ballast is an important component that maintains a stable discharge inside the fluorescent tube, which in turn results in a stable light output. 2. Compact fluorescent lamps, CFL. The common name of CFL is energy-saving lamp. Its structure is similar to a FTL except that it is twisted and coiled. 3. High-density discharge lamps, HID lamps. HID lamps are more efficient in producing visible light than FTLs. It is usually used for high-output applications. HID lamps are filled with mercury, sodium, and metal halide gases. They work at higher voltage than ordinary FTLs or CFLs. Do check point 1 below.